Okay, section 1.5G, homeostasis, negative feedback summary. Let's look at the 4 negative feedback mechanisms that we've studied so far, one by one. So first of all, let's look at temperature. The set point for normal body temperature is 98.6 Fahrenheit, and again, there is a normal range. You can be a little lower, a little higher, but for our purposes, let's go with a set point of 98.6 degrees Fahrenheit. If your temperature raises too high, two things will kick in. You will start to sweat, so your sweat glands will be prompted to produce sweat. And secondly, you will shunt blood to your skin, thereby being able to lose some body heat via convection, conduction, and radiation. Conversely, if your body temperature is too low, you will shiver and you will shunt blood to the core. In this case, you will turn pale. In the case of your body temperature being too high, you will turn red. Glucose, the set point is 70 to 110 milligrams per deciliter. When your glucose is running a little high in the bloodstream, when your serum glucose is high, we're going to secrete insulin. That will be the effector. Conversely, if your glucose is low, you're going to secrete glucagon, which will then hopefully raise your blood glucose to within the normal range. Serum calcium should be between 9 and 10.5 milligrams per deciliter. If your calcium levels are running a little high, you will produce calcitonin as the effector, which will store extra calcium in your bones. Conversely, if your calcium is running a little low, you will produce PTH, which is parathyroid hormone, which will then prompt your specialized bone cells to break down bone, release calcium into the bloodstream, and thereby raising your blood calcium levels back to within normal range. Blood pressure is 120/80, and I forgot the units there. It's millimeters of mercury, mmHg. Units, units, units! So the effectors, as we did in 1.5F, we're going to look at the too low scenario first because that makes more sense. So when your blood pressure is too low, you're going to jack up your heart rate and you're going to shunt blood to your core, thereby looking pale. Whereas when your blood pressure is too high, your heart rate's going to drop and you're going to shunt blood to your skin, thereby causing your skin to look red or flushed.